All right, let's get right into it. We've all got dashboards, right? We've all got alerts. But here's the real question. When a major system-wide slowdown actually hits, does your monitoring just tell you that something's wrong, or does it actually help you figure out why? Today, we're going to blow past those basic health checks and really dig into how you can detect and diagnose the performance bottlenecks in today's super complex software.
You know, this quote really nails it. In the world of distributed microservices we live in, things going wrong isn't an if, it's a when. And it almost never happens in a nice, clean, predictable way. No, we're talking about these bizarre, cascading failures that just ripple across all your services in ways you could never have possibly planned for.
And this is a feeling every on-call engineer knows in their bones. It's the middle of the night, that dreaded pager buzz goes off, and you're just staring at a dashboard. All your little service health checks look fine. CPU is okay, memory's stable, but the main business metric? It's tanking. So where on earth do you even start looking? That feeling of being totally lost, surrounded by green dashboards while the whole ship is sinking, that's a direct symptom of complexity. We used to have these big monoliths, right? You could trace a problem through a single code base. But now it's a giant web of services talking to each other. And the real problems? They love to hide in the gaps between them. And this gets us to the absolute core of the issue. The metrics we've all been taught to trust can actually lie to us. We're so conditioned to look at averages, but in a big distributed system, the average is a total fantasy. It's a number that hides the real pain your users are feeling. To make this real, just think about hailing an Uber. That one little tap on your phone, it can end up touching something like 500 different microservices before it's done. That is 500 different chances for something to be just a little bit slow. This is what's known as the tail at scale problem. Your user's experience isn't based on your average request time. No. It's defined by the slowest single part of that entire chain. The request is only as fast as the slowest of those 500 services it happened to hit. And this is how those rare, slow moments become incredibly common. I mean, the math here is just brutal. If you have just 10 services, and each one has a tiny 1% chance of being slow, the probability that your user gets a slow response is almost 10%. That variance just multiplies with every single network hop. So, if the average is a lie, what should we be looking at? This is where we have to completely change how we think about measurement. We need to start measuring the actual user experience, not just the health of the machine. And this is the question you need to take back to your team. Seriously, go look at your main dashboards. Are they just full of average CPU and mean response times? If the answer is yes, I guarantee you have huge blind spots. The real answer lies in understanding percentiles, specifically P99 latency. See, the average gets dragged down by thousands and thousands of superfast requests, and it totally hides the painful outliers. But P99 latency? That tells you the experience of your unhappiest 1% of users. It tells you the worst-case, real-world performance that somebody is definitely having, right now. And this chart just says it all. Your average latency dashboard might show a beautiful, healthy 100 milliseconds. The team's giving high fives. But the P99 metric reveals the ugly truth. 1 out of every 100 requests is taking a full 2 seconds. That's not some rare event. That's a user getting frustrated and closing the tab. That's a support ticket waiting to happen. The engineers at Google's SRE teams boiled this all down into what they call the 4 golden signals. And notice what's right at the top: latency. But not just the average, the entire distribution of latency. Along with that, you need to be tracking traffic, your error rates, and saturation, which basically tells you how close you are to maxing out your system. Okay, so we're tracking our P99 latency, and it's bad. We know what is slow, but that's only half the battle, right? Now we've got to figure out where the slowness is coming from. In a system with 500 different services, how do you find that one needle in a giant haystack?
Well, this is exactly the problem that distributed tracing was invented to solve. It's basically a way to follow a single user request on its entire journey as it hops from one service to another, from the front door of your API gateway all the way down to the database and back again.
And this is where it just becomes so incredibly powerful. With a single view like this one, the problem just jumps out at you. A trace gives you this waterfall view of a request's life. You can see the API gateway was fast, auth was fine, the user service was quick, and then, boom, 450 milliseconds just vanished inside a single database query. There it is. There's your bottleneck. So here's the bottom line. If you're running microservices and you're not using distributed tracing, you are flying blind, period. It is the single most important tool you can have for understanding where time is actually going.
It turns an impossible mystery into a solvable engineering problem.
Now, having the right tools is crucial, but it's not the whole story. We also have to develop the right mindset. And that's the big shift from just doing monitoring to practicing true observability.
Think of it like this. Monitoring is for the problems you already know about, the known unknowns. You watch CPU because you know it might go high. But observability, that's for the problems you can't even imagine yet, the unknown unknowns. It's the ability to ask brand new questions of your system when something surprising happens, without having to guess which dashboard you should have built 6 months ago.
Real observability is built on what folks call the 3 pillars. You've got your metrics, like that P99 latency we've been talking about. You've got your logs, which give you all the nitty-gritty details. And you've got your traces, which tell the complete story of a request. The magic happens when you can jump from a spike in a metric to the exact traces that caused it, and then to the logs from those services. That's when you can really understand why things break.
Okay, so let's get super practical. How do you actually put all this into action? Here is a real-world, 5-step playbook you can use to hunt down and fix those performance bottlenecks.
Let's walk through this, because this is where the rubber meets the road. First up, instrument everything and set budgets. For every single user-facing endpoint, you need to know your P99 latency, and you need to have a team agreement on what's acceptable. That's your SLO. Next, step 2, find the culprits. Use your tracing tool and figure out which services are always showing up in your slowest requests. Don't try to fix everything at once, just find the top 3. Then, step 3 is about the easy wins. Dig into those services and look for common performance anti-patterns. Are you seeing N+1 queries where one loop makes hundreds of little database calls instead of one big one? Are your services being too chatty? Step 4 is where you get defensive. You can't eliminate all slowness, but you can control its impact. Set hard deadlines on your network calls. Use smart retries with jitter, which adds a bit of randomness to stop a retry storm. You can even do things like request hedging for critical stuff. And finally, step 5 is all about resilience. Use patterns like bulkheads. Think of them like watertight compartments on a ship. This way, a failure in one small service gets contained and can't sink the whole application. This is your playbook. This is how you go from being reactive to proactive.
And this quote just perfectly captures the culture shift that has to happen. Performance isn't a feature you ship and then just forget about. It's a discipline. It's a continuous practice that requires the right tools, the right metrics, and a culture that treats performance as a core part of everything you build.
So let's just quickly recap the big ideas here. 1. Stop looking at averages. Your P99 latency is your new North Star. 2. If you have more than a couple of microservices, distributed tracing is not optional, it's essential. 3. Build for observability. Give your teams the power to ask why. And 4. Treat performance like a discipline, not a one-time project. And so I'll just leave you with this one question. The next time that pager goes off, the next time you see that dreaded latency spike, are you going to be staring at a useless average on a dashboard? Or are you going to have the X-ray vision to see exactly where the problem is and how to fix it? Because honestly, that difference is everything.